Okay, so this is the beginning of chapter 4, page 129. Not a good time. Thank you. So it says Javier is helping his parents put up posters in their movie theater. Each poster has a thickness of 0.012 of an inch. How thick is a stack of 10 posters? 100 posters? 1,000 posters. And it says, solve this problem any way you choose. Well, this is actually similar to that Google problem. I think you guys remember that I put up a picture of a flower that I took. And I had my, sort of my thumbnail by the picture, and I was talking about it and asking you how big the flower would be if it was 10 times or 100 times or 1,000 times larger, or 10 to the first and 10 squared and 10 cubed. And you guys should know that would be 10, and this would be 100, and this would be 1,000. Okay? So, if we take 0.012 and we multiply that by 10 posters times 10, okay, all you're doing is moving the decimal one place. There's 1 0. You're going to move it one place. So here's the decimal. And what you have to remember is that you're making the number larger. And so when you're making the number larger, the decimal is always moving to the right. Larger, the decimal moves to the right. So I'm going to move the decimal one place. So it would be 0.12. Okay? Well, yeah, I could add a 0 after the 2. I could add 100 zeros after the 2. It wouldn't change the value of 0.12. So that was 10. And what if it was 100 posters? Well, that means I'm going to move the decimal, 0.012, 2 places. 1, 2. So now it becomes 1.2. So that's 100 posters. And then 1,000 posters, it's 0.012. I'm going to move the decimal 3 places. 1, 2, 3. And now it becomes 12.
Just 12?
Okay. Well, 12, actually I should be labeling each one of these as inches. And so I'm just going to square this off. So that's my answer. 0.12, 1.2, and 12 inches. So if there was 1,000 posters, 1,000 pieces of paper at this thickness, it would be 12 inches thick. Okay? Questions on that? All right, I'm going to scratch out the bottom. Not worried about that. You guys can do that too. Next page. Page 130, it says you can use place value and what you know about whole numbers to multiply decimals by powers of 10. And it says, what patterns can you find? And so here they have 363 times 1, and that's going to be 363. 363 times 10, or 10 to the first, it's the same thing. You're going to add a 0. 1 0. In this one you're adding 2 zeros. This one you're adding 3 zeros. The number's getting quite a bit larger. And they talk about, in a place value chart, the same pattern appears when a decimal is multiplied by the powers of 10. So they're doing it, they're doing it pretty much the same way I showed you a moment ago. They're just moving the numbers over. So it was 3.63, and then when you multiply it by 10, you move the decimal over 1, and now it's 36.3. Multiply it by 10 squared, it's now 363.00. And so they're adding the zeros, and you're moving the decimal. Okay?
Oh, you just moved. Okay.
So in this one, they're shifting the number this direction, but the decimal is staying, it's moving this way because we're making the number larger. So they just did a little bit differently than what I explained before. Okay? What do we have here? Okay, let's look at this chart. I'll do the top, and then I want you guys to do the other ones. So 1.275 times 10. So it's getting larger. I'm moving the decimal that direction. So this would be, if I move the decimal over one place, it's going to be 12.75. Now I'm moving it two places. So now it's 127.5. Now I'm moving it three places. It's going to be 1,275, and I'll just put the decimal right there at the end. I want you guys to finish that on your own. Okay, hang on with the questions. All right, next page. It says, do you understand when multiplying by a power of 10, like 4.58 times 10 to the third, how do you know you are moving the decimal in the correct direction? Well, let's see here. When I multiply by the power of 10, the number gets larger. And if you still get confused as to which direction you're moving a decimal, when we're talking about the number getting larger, if I had 0.12, if I wanted to make that number larger, I would move it in that direction, because you know 0.12 is smaller than 1.2. And certainly 1.2 is smaller than 12. And you know that 12 is certainly smaller than 120. Okay? So if you're multiplying by the power of 10, the number is getting larger. Always getting larger. All right, find each product. So I'm going to do number 2 here for you. It's 0.009 times 10, so that's by the powers of 10. It's getting larger. Which way does the decimal go when we're making the number larger? You know, it goes to the right. So this is, I'm going to move it one place to the right, so it's going to be 0.09. Okay. Number 4 here, again, it's getting larger. It's now two places, so 1, 2, so it's going to be 6.2. Okay. Let's move down. Let me do the first one on number 7 here. 0.086 times 10 to the first. I'm moving the decimal one place, so it becomes 0.86. How many places am I moving it here? Twice. So it becomes 8.6. How many places am I moving it here? 3 places. 1, 2, 3. So it becomes 86. And I'll just put the decimal right there. Okay. And in number 6 here, I'll just do the first one. Well, actually, the first one is easy. Anything times 1 is itself. So that's 42.3. If we multiply it by 10, we're making it larger. Which way does the decimal go? It goes to the right. So this becomes 423. I'll let you do that last one on your own. Let's do a couple of these together. Let me pull a stick and somebody can pick one that they want me to do. Mr. Leva, what number should I do, 8 through 15? Pick one. Go ahead and pick one. Which one? 12. Let's look at 12, he says. Okay, so 94.6 times 10 to the third. I'm going to pull another stick here. Mr. Burns, is he in here? Nope. Another stick. Miss Schlegel. How many places am I moving the decimal? 3 places, that's right. And so I've got, if you look at this, 94.6, I don't have 3 places to move the decimal. So I'm going to have to add some zeros. So I'll just add a couple zeros here. So 1, 2, 3. That's where the decimal goes. So the answer is 94600. And the comma goes 3 places over right there. So it's 94,600. Okay, Mr. Kimmel, do you understand that? Okay. Ms. Schlegel, put up 10 points. Mr. Myers, number 14. Do that one for me. How many places am I moving the decimal? Yeah, 2 places. Okay. So 0.678. 2 places, which way, to the left or right? Yeah, we're going to the right. Okay. Where's the decimal end up? What? Okay, so 1, 2, that's right. So this becomes 67.8. All right. Next page. So it says, Monroe uses the microscope to observe specimens in a science class. The microscope enlarges the objects 100 times to their actual size. Find the size of each specimen seen in the microscope. So let me pull a stick here. Miss Powers, how many places are we going to move the decimal in each specimen? 2 places, that's right. Okay. So, Miss Powers, I'm going to keep picking on you. We're going to do the very first one here together. It's 0.008. Where does the decimal end up? In front of the 8. So 1, 2 places. So it's going to be simply 0.8. Okay, good. Put up 10 points. John's binoculars enlarge objects to 10 times their actual size if the length of an ant is 0.43 of an inch. What is the length seen up close through his binoculars? Miss Vance, let me ask you a question. How many places am I moving the decimal? One. So what would this become? Which way am I moving the decimal? Yes, this way. So what's it become?
4.3.
Thank you, 4.3. Okay. Oh, put it in points. I forgot to label it. 4.3 inches. That's correct. And actually, technically, if you look over at this one here, when it's in a column like this, in a way, they've already told us that all of these are centimeters. But if you put cm, it's probably a good habit to have there. All right. Let's look at 24. Last one here. Jose ran 2.6 miles and Pavel ran 2.6 miles. Who ran further? Explain your reasoning. Oh, interesting. So, right, I even, by accident, I read them both as 2.6 and 2.60. So, Mr. Papke, I don't know. How would you explain that? What would you? Well, first off, who ran further? Yeah, both ran the same. And then, gosh, how would you explain your reasoning? What would you say to that?
Because the 0 on 2.60 miles just
That is beautiful. Put up 20 points. The 0 does not change the value of 2.60. Yeah, that was nicely put. Nicely put. Okay? All right, so there's your work. And estimate. I want you guys to work on that quietly for a few minutes. I'm going to end this video. Wow, a whopping